Hello everyone, welcome to our new science video. Today we're gonna talk about concept 2.2. This concept is talking about heat transfer. Look at this picture and answer. Do the hand and the hot cup have the same temperature? Of course no. When we touch a hot cup of tea, we will feel the hotness of the cup. Do you know why? Last concept, we said that the heat transfers from the hotter object to cooler object. The hotter object has higher temperature, but cooler object has lower temperature. But do you know what happens to an object when heat is transferred? Actually, the molecules in object with lower temperature will start move faster as it gains thermal energy, while the molecules in object with higher temperature will move slower because it loses some thermal energy. So, look at this picture in front of you. Can you tell me what happens to the lizard when heat is transferred? The rock absorbs thermal energy from the sun rays, so the molecules of the rock move faster. The skin of lizard absorbs thermal energy from the rock. The molecules of the rock will move slower, while the molecules in the skin of the lizard move faster. So, you can answer it by yourself. Do you know what happens to the boy or to your body when heat is transferred? So, heat is the transfer of thermal energy caused by a difference in temperature between molecules. The measuring unit of heat is calorie. Heat transfer has some properties. Number one is heat is an essential component of life on Earth. Without heat from the sun, there will be no life on the Earth. Number two, heat flows from a hotter object to a cooler object. Number three, heat can be lost, but it's only transferred from two objects. Thermal energy relates to the total sum of the kinetic energy of molecules and atoms of a substance, as we said before in the last concept. So, any substance has thermal energy, even the cold substance, as they have molecules that always move. Thermal equilibrium. To understand what is thermal equilibrium, look at this picture. As we said before, that heat transfers between two objects that have difference in temperature, as the heat transfers from hotter object to cooler or lower object. The heat will keep transferring from hot object to cool object till they have the same temperature, and that's known as thermal equilibrium. In thermal equilibrium, both objects have the same temperature. So, when both objects have same temperature, the heat will stop transferring between them. So, how to calculate the average of thermal equilibrium? If we have two different cups, A and B, if we measure the temperature in A, you will find it's 60 Celsius, and in B, you will find it's 10 Celsius. By mixing the two cups together in another beaker, which is C, can you guess the temperature in this cup will be how much? Actually, to calculate the average of thermal equilibrium or the temperature in cup C, we should follow this rule. It's the summation of two cups divided 2. So, we're gonna write 60 added to 10 divided 2, it would give you 35 Celsius. By waiting 3 minutes, bring thermometer and measure the temperature in cup C. You will find that the temperature or the final temperature of water after mixing is 33. As you can see that the final temperature of water after mixing always less or lower than the average temperature. So the final temperature of water almost equals the average temperature of water that we have calculated before. But do you know why aren't the final temperature and the average temperature equal? Because some of thermal energy transfers to the air or the container. So what will happen to the motion of molecules after mixing? The molecules of hotter substance become slower. The molecules of cooler substance become faster after mixing. Do you know why don't we feel any hotness when we hold the handle of the electric iron during ironing? Actually, the handle of the iron is made of plastic, which is considered as thermal insulator, while the base of the iron is made of iron, which is considered as thermal conductor. But what's the difference between thermal insulators and thermal conductors? Thermal conductors, they are materials that allow thermal energy to transfer through, while thermal insulators, they are materials that resist or slow down the transfer of thermal energy. Thermal conductors, such as all metals like copper, iron, aluminum, while thermal insulators, such as plastic, wood, glass, and air. Thermal conductors are materials that allow heat and heat travel freely through them, while thermal insulators, they slow down, as we mentioned before, the heat to transfer through them. We can tell that thermal conductors are good conductors of heat, while thermal insulators are bad conductors of heat. Thermal insulators can't prevent the transfer of heat completely, but they just slow down or resist the heat transfer through them. Let's take some examples to understand the difference between thermal insulators and thermal conductors. If we have two cups, one of them is metal and the other one is plastic. Can you tell in which one you will feel heat transfer first or faster? Of course, metal pot. Do you know why? Because metal is a thermal conductor that allows thermal energy to transfer through, while plastic pot is a thermal insulator that slows down the transfer of thermal energy. Look at this picture and answer this question. Why do we feel that the metal doorknob is cooler than the wooden door? Actually, the thermal energy transfer passes from hand to the metal doorknob as a thermal conductor. And thermal energy transfers slowly from hand to the wooden door as a thermal insulator. So, look at this picture and tell at which point the temperature would reach its peak. The measurement of temperature differ from one place to another, where point A has the highest temperature because it's the nearest point to the source of heat, and it gets cooler as we go far away from the fire. Just add to your information that if you have two pots with different handles, one of them is made of plastic and the other one is made of wood, which one will get warmer first? Okay, the wooden handle warms up faster than the plastic handle. Heat can transfer by three different ways: conduction, convection, and radiation. So, what's the difference between them? Conduction, when objects with different temperatures touch each other, and it must transfer between two solids, like the fever cooling patch. So, conduction happens between solids only. Convection, due to the movement of liquid or gas. The hot water moves up to the surface while cold water moves down to the bottom. The movement of water causes the transfer of heat through it. Radiation happens through gases and space, like feeling warm beside the fire or in the morning due to the transfer of thermal energy through air and space. So this picture shows you the three different ways of heat transfer: conduction, convection, and radiation. The speed of heat transfer between objects increases when the difference in temperature between two objects increases, the surface area of objects increases, the time of contact between objects increases. There are some careers that depend on studying the ways of heat transfer, like meteorologists. Meteorologists, those are scientists who study weather. They must understand convection and radiation to help them predict the weather. Number two is engineers. They must understand convection, conduction, and radiation to design new products such as tools of cooking and shadier sidewalks. So, we have said before that matter can be changed from one state to another by heating or cooling, or by increasing and decreasing temperature, or by gaining and losing thermal energy. So, does the mass of the matter change from changing it from one state to another? No, of course no. Because of the law of conservation of mass. The law of conservation of mass says that the mass of the substance doesn't change when this substance changes from one state into another. So, does the mass of popcorn change after cooking? In this case, it's yes. Do you know why? The mass of the popcorn will decrease after cooking due to the evaporation of the water. There are some cases that the mass of the substance before the change doesn't equal the mass of the same substance after the change, because the substance is mixed with other substance. The mass doesn't change even when any liquid substance changes into gas state. Look at this picture. By putting marble on the top of the ramp, make it store the highest potential energy. And by moving the marble down, the potential energy that is stored inside it changes into kinetic energy. So, will the marble reach the end of floor if we let it fall from the top of the ramp? Will the marble keep moving forever? Of course no. Do you know why? Because some kinetic energy changes into thermal energy due to the friction force between the marble and the floor or the track. That decreases the speed of the marble so it doesn't reach the end of the track. By using large marble, make it moves faster downward. Do you know why? Because it has a larger mass, so it gains more kinetic energy. The same happens in this picture. When a bicycle goes down a slide, its potential energy changes into kinetic energy. The bicycle stops after some time because there is a friction force between the tires of the bicycle and the road. So, some of the kinetic energy changes into thermal energy due to the friction force. Now let's talk about properties of new materials. Scientists and engineers choose the most suitable materials with some useful properties such as flexibility and conduction of heat to make the products that people want, and they develop new materials by focusing on some specific properties. Let's take some examples to understand. To make clothes, scientists use soft material. Scientists develop a smart material or smart cloth, which is flexible fabric that controls the body temperature, light up in the dark, keep themselves clean, like this picture in front of you. When scientists develop new materials, they study the structure of molecules of materials to understand their chemical structures that help in understanding their properties. So, how are new materials created? By different materials together, like formation or creation of steel. Steel is a mixture of iron and other elements. Steel is very strong and lasts for a long time without rusting like iron. Number two, concrete. Concrete is a mixture of rock, sand, and water. Actually, concrete becomes hard when it dries. Concrete is used as a base of buildings and bridges as it's very strong. Now let's talk about creation of plastic. Some materials are created due to the chemical change, like creation of plastic. We use petroleum to make plastic. So, petroleum is the original material that we use to create new material. The properties of petroleum is it is a liquid, it burns easily. But plastic is very tough and solid and it often resists burning. The properties of these materials differ from the properties of the original material. Creation of new materials by mixing materials at high temperature happens in two examples. Number one is shrink wrap and formation of glass. Glass is a mixture of sand with small amount of limestone and soda ash or sodium carbonate. Glass is made when the sand mixture is heated in hot furnace, so it melts and changes into glass. Then the glass becomes hard when it cools. I hope you got this concept. Thank you for listening.